What's up, guys? This video is about Pythagorean Theorem, which some of you may have learned from algebra or 8th grade math. And then the picture there is Pythagoras, the man who invented the Pythagorean Theorem. Alright, so given a right triangle, ABC, that's important because the Pythagorean Theorem only works for right triangles. Okay, so given a right triangle, we're going to label the sides opposite of each angle. So if you recall from the beginning of geometry, we always label a point with a capital letter. We're going to label the side across from it with its corresponding lowercase letter. So this side is lowercase a. Opposite of angle B, we're going to label side B. And then opposite of angle C, we're going to label side C. Okay, so another important fact about right triangles is that the hypotenuse is always the longest side across from the 90-degree angle. So across from 90 degrees is always the hypotenuse, which is the longest side. Okay, the other two sides, A and B, are smaller than the hypotenuse, and we refer to them as the legs. Okay. You probably recall from the activity that we did in class with the little squares that you had to arrange that when you square both the legs and add them together, it is equal to the square of the hypotenuse. Okay, so remember, it kind of looked something like this, where you had like your little squares, and the area inside of the squares, a squared and b squared, was equal to the area of the hypotenuse squared. Okay, so that little activity leads us to pretty much prove that the Pythagorean theorem is true for all right triangles. Okay, this theorem is going to take you all the way through the remainder of the year, so write it down, remember it, understand it, make sure that you know that C is always the longest side. Okay, so now we're going to try a few examples together. Go ahead and get yourself set up with these 3 examples, and then we will walk through them together. So the first example, well, the first thing you have to do is figure out what's the missing side they want me to find. Do they want me to find A, B, or C? Because it does make a difference according to our formula. So an easy way to do that is always look for C, look for the hypotenuse, which is across from the 90-degree angle. That's not given to us, so that must be what we're solving for. Again, A and B, it doesn't matter which is which, so you can feel free to label either one, either 7 as the A or 7 as the B. And then we're going to plug in our numbers to our formula. So again, A and B, our legs, are going to go on the left-hand side. So 7 squared plus 5 squared equals C squared. Now we're going to simplify. 7 squared is 49. 5 squared is 25. Add them together to get 74. Now I need to get C by itself because C squared is 74. I just want to know what's the length of C. So to undo a power, we're going to take the square root. It's a radical, guys. It's like one of our previous videos. So we always want to check, can this radical be simplified? Do any perfect squares go into 74? No. So that means we're going to leave our answer as a radical. Don't get a decimal, because if you get a decimal, if you type on your calculator, what's the square root of 74? If you tell me 8.6, that's not correct, because you're leaving off all this value. So just leave it as a square root. It makes it easier. You don't need to type it. Just leave it. Okay, second example. We'll make this side 12 and that side 8. So we want to find our missing side. Look for C always first, so I'm going to find my 90 degrees. C is given, C is 12, so I'm going to find A. If you labeled it as B, that's fine, it doesn't matter. Now we're going to plug in a squared plus b squared. I chose to make b 8 is equal to 12 squared. 8 squared is 64, 12 squared is 144. Subtracting the 64, we get 80. And again, to undo this power, we're going to square root it. So a is the square root of 80. Okay? Now, I know I told you to leave the square root because remember that one could not be simplified. So anytime you have a radical, you always want to see if it can be simplified. Does any perfect square go into 80? If you forgot your perfect squares, you can pause the video right now and go ahead and start making a list of them on the side of your paper. Some people find that to be helpful. Okay, I'm going to stop at 49. So just by looking at my list here, 4 definitely goes into 80. But remember, we want to always test to see that highest perfect square that might go into 80. So I'm going to test 16. See what it comes out to be. 80 divided by 16 comes out to be 5. So now that's going to give me 4 root 5. If you're unsure of how I got this, I would highly recommend that you pause this video, go back to the start of Unit 1, and re-watch that simplifying square root video just to refresh your memory. Okay? Alright, so let's go ahead and make our this side 5 and this side 13. So again, we're solving for a leg. I'm going to call it A. Go ahead and set up your equation so it should look very similar to example 2. A squared plus 5 squared equals 13 squared. And go ahead and continue doing this problem until you figure out the final value for A. Okay, so once we get to the end of this problem, we notice that A comes out to be a whole number. So we did not need to simplify a radical like we did in example 2, which is super great. Whenever this happens, when you have 3 whole numbers as your side lengths for a right triangle, and the Pythagorean theorem works for it, this is called a Pythagorean triple. Okay, so we talked about one example in class when we did the little square activity. So that was the 3, 4, 5 triangle. Here's another example, 5, 12, 13. There are a ton more examples. If you are interested in knowing these, it will just allow you to do problems faster, but it is not a requirement to memorize these. Oh, one more would be 7, 24, 25. That's a common one that shows up also. Okay, example 4. Go ahead, pause the video for a quick minute and copy down this problem. And after you're done copying down this problem, I want you to think about what the diagram might look like for a problem like this. So we are asked to find the height of an equilateral triangle with side lengths of 20. So hopefully we know what an equilateral triangle is from last year. If you don't already know, an equilateral triangle is a triangle where all 3 sides are the same. And it tells us the specific length of that triangle. Side lengths would be 20 inches. So I'm going to draw the triangle to the best of my ability so that all 3 sides look to be about the same. And I'm going to label them all 20 inches, right? I need to figure out the height of this triangle. So the height of a triangle is always formed making a right angle to one of the sides. Okay, so because this is an equilateral triangle, once I draw that height in there, I know that these 2 segments are going to be equal. And since they add up to be 20, they both must be 10. Right? So really, this is a Pythagorean theorem question. Even though it's not for a right triangle, there is a right triangle within this problem. So it may be helpful to you to redraw this diagram And we're always looking for C first, right? So I'm solving for a leg here. You can call it A or B. It's up to you. I'm going to call it A. Okay? I think you guys can take it from here. Go ahead and solve for the value of A, and then when you're done, click play and see if you got the answer correct. Great. If you got that A is the square root of 300, that means that you are able to use the Pythagorean theorem correctly. But if you left your answer like this, that means you forgot to simplify your square roots. Okay? So always check that list of perfect squares. What perfect square goes into 300? That would be 100 times 3. So the final correct answer for the value of A would be 10 square roots of 3. And since they gave us a unit up here, I would also want to add inches. Example 5, I think, are the easiest types of examples. Even though there's no picture, they give you the information so directly, you can plug it right into the formula. So the question is, find the missing side of a right triangle with legs A and B and the hypotenuse C. So all we're doing is taking these values and plugging them into our theorem that we just learned to find our missing value. And they give them to you directly. So I'd like you to try these on your own. Click play, see if you got them. So here are 2 correct answers to example 5. However, I am going to continue because if you left your answers like this, you may have forgotten to simplify your square roots. Since 149 is a prime number, we're just going to leave that one as is, but 200 definitely has a perfect square factor of 100, so your final answer for this one should be 10 root 2. We're going to go ahead and do one more question together, so flip your notebook to a fresh page. This is going to be a real-world problem. All right, last example. Find the original height of the broken tree. Okay, so I drew a little diagram, bear with me here, I'm not an artist, of a tree that broke and fell over onto one side. So the section of the tree that is still standing is 6 feet tall. And the distance from that part of the tree to where the tip of the tree has fallen is 8 feet. So we want to find the original height of the broken tree. That means the entire, both pieces of the tree. So that 6 feet plus whatever this is, which we need to figure out, right? And since that is across from the right angle, that is our hypotenuse. So this is a 2-step problem. Step 1, find the length of our hypotenuse. Find C. Step 2, add the 6 feet plus whatever we get for C. Okay? So we're going to set up our Pythagorean theorem again. So adding these together, we get 100 equals C squared, square root that. We get 10. 10 is the missing part of that broken tree. The entire tree is not 10 feet though. The entire tree is the 6 plus 10. So the height of the tree is 16 feet tall. That pretty much summarizes all we're going to do with the Pythagorean theorem right now. Hope this video was helpful. There's a couple more videos on the website for you to view if you need some extra help.